In our previous look at rational numbers, we've looked at them as a ratio or as a fraction. In this chapter, we're going to start looking at decimals and percents. So we're going to take a look at finite decimals here in the first section and the connection between a fraction and a decimal. The word decimal is coming from the Latin word decim, which means 10, and it kind of pays homage to the fact that we have a system that is in base 10. So each place behind the decimal is incrementally increasing by that base of 10. So because of the base 10 methods, we can start displaying decimals as, instead of the multiplication by the powers of 10, like the base 10 system, once it's behind the decimal, it's the division. So the 6 is in the 10th place, so it's 6 over 10. The 1 is in the 100th place, so it's 1 over 10 squared, which is 100. So it's just, this is really just kind of connecting the name of the decimal place to the powers of 10, like we saw in the different systems with the bases of different values. So if I read this number out loud, it would be 12 and, so the decimal place is read as an and, 61,843 hundred thousandths. Each place behind the decimal is named by its power of 10, and notice we're just putting that th ending on it. So instead of tens, I have tenths. Instead of hundreds, I have hundredths, thousandths, 10,000ths, and then 100,000ths. When I'm naming a decimal like I did here, you name the place that's all the way at the end. So if I look, I have tens, hundreds, thousands, 10,000s, 100,000ths. So that's why this says 100,000ths at the end, because you only name the decimal that is all the way at the end. So if we're looking at base 10 blocks, this can be kind of difficult to help students transition to the idea of a decimal. So what we start doing with the idea of a decimal is we start looking at them as fractions. So if I have one of the blocks, it's 1 of 10, because I like to stack them into columns of 10. So then we can look at, this is the representing a part of the whole row, which is 10. And then we can also start stacking our cubes together. And if we want to look at 54 hundredths, because it's normally a stack of 100, we can start looking at that, or we can look at improper fractions. So to represent a decimal such as 2.235, we can think of a block as a unit. So this is 1, this is 2, and then 0.235. And notice what's happening here is they get smaller and smaller as I get further out in the decimal, because there's a smaller and smaller place value for those small decimals. So if I wanted to convert each of the following to a decimal, the easiest way to do this is to just type into your calculator 25 divided by 10. We don't have to worry about remainders here, so this is not math that we can avoid with a calculator. So we could type all of these straight in, or we could use place value, and we would be able to understand where these went. Now, if I use place value, 56 over 100 means that I have 56 hundredths. 205 over 10,000 would mean that I have 205 10,000ths. So that's why this is written here, but you could also use division. If I wanted to express these as decimals, this is a little more complicated because I don't have powers of 10, but you can type in 7 divided by 2 raised to the 6th power in the calculator to get this answer. And that's perfectly acceptable because we're not really working on exponents with our elementary kids at this point. We're just working on basic decimals. This is the added layer of difficulty for working with teachers. So you can type these in. Now, when you type 1 over 2 to the third times 5 to the fourth, you will have to put parentheses around 2 to the third times 5 to the fourth so that your calculator knows that entire quantity is in the denominator. So you would do 1 divided by, open parenthesis, 2 to the third times 5 to the fourth, close parenthesis, and that should give you this decimal. Here are some other examples. Again, we're just doing simple division. And so the big idea here is that when we teach students decimals, we don't want them to see decimals as a completely separate facet. We want them to see that a decimal is simply a representation of a fraction. So we're really trying to build that connection and that understanding here for students. Terminating decimals are decimals that have a clear end, so they don't continue on forever. A rational number in simplest form can only be written as a terminating decimal if and only if its prime factorization has no primes other than 2 or 5. So when I look at 16, I can write that as 2 to the 4th. 2 is the only prime number, we're good to go. 18, though, has 2 and 3 as factors, and I can't use, it's going to it can't be written as a terminating decimal because it has 2 and 3. We're only allowed 2 and 5. Same thing here, 2 and 5, good to go. 2 and 13, nope, it's not going to be able to be written as a terminating decimal. So this is just kind of a shortcut so you're not having to actually complete the division here. If I want to order my terminating decimals, it's going to be located on the number line, and you're going to be placing it between values. If you're ordering terminating decimals with the same denominator, you use the numerator in order to order the decimal. So if I'm comparing 0.67643 to 0.6759, I'm going to look at this and I'm going to line them up. It helps to write them vertical. So I line them up and I start at the left to see what's in common. Well, I have a 6 is in common, a 7 is in common, but then the 6 is greater. So because the 6 is greater right here in this step, we know that 0.67643 is greater than 0.6759.